Okay, so we're doing chapter 9, problem 41. So we have this 3 kilogram block sliding frictionlessly along its tabletop at 8 meters per second, and it hits this second block that's at rest with a mass of 4.5 kilograms, but it has a spring on it with a spring constant of 850 newtons per meter. So part A says, what is the maximum compression of the spring? Okay. So we know that at the maximum compression of the spring, the blocks will not be moving relative to each other. They would be exactly the same. And all of the interaction between the blocks is internal to the mass spring system. So that means that momentum conservation can be used to find this common speed. So what we mean by that is P initial equals P final, meaning that M1 V1 equals M1 plus M2 times this V prime, which is a common speed of them moving together at maximum compression. Okay, so we also know that the mechanical energy is conserved. So we can find the energy stored in the spring and then the compression of the spring. So what that means, energy conservation, E initial equals E final. This means the initial energy, which is just the kinetic, equals our final kinetic energy, V prime squared, plus the amount stored in our spring, the potential energy stored in the spring. Awesome. So now we can just solve this for what x is. So if we rearrange this for x, we get this large equation of 1 over k times m1 m2 over m1 plus m2 times v1 squared. Awesome. So this was just solving this for x with both of these equations. Okay, so we know all of these things now, so we can just plug this in. So we get the square root of 1 over 850 Newton per meter. Then we have 3 kilograms times 4.5 kilograms over 7.5 kilograms times 8 squared meters squared per second squared. Cool. We plug all this in, we get an answer of x being 0.37 meters. That is our maximum compression. Awesome. Let's move on to part B. So now we just want to find the final velocities. Well, we should already know that this is an elastic collision. So that's the answer to part C, actually. We'll jump ahead and said, is this collision elastic? Well, we know it's going to be because all the forces are conservative, because there's no friction. If there was friction, then that's a non-conservative force. But since all the forces here are conservative, we know that it is elastic. Okay, so moving back to part B, since it's elastic, we can use simple equations to find the final velocities. So we can look back at example 9.8 or problem 40, and we can solve these. So for a stationary target in elastic collision, we have V1 prime is V1 times M1 minus M2 over M1 plus M2. So let's find that out. So this is 8 meters per second times negative 1.5 kilograms over 7.5 kilograms. So we get a final velocity for V1 prime of negative 1.6 meters per second. Cool. We can do the same thing for V2 prime, and this becomes V1 times 2m1 over m1 plus m2. Cool. So this is 8 meters per second times 7 kilograms over 7.5 kilograms. Sorry, that's not 7, that's 6. 3 times 2 is 6. Simple math. Okay. 6 kilograms over 7.5, and this comes out to be 6.4 meters per second. Cool. We got all the answers there.